Hello, this is Peter from Onecnc UK, and in this video we're going to take a look at just some of the advantages of upgrading from XR9 Professional to 10 Expert. So let's get started. The only visual difference you will see when you open Onecnc10 is a 3D view cube has been added to the lower left corner of the screen. This allows you to easily select interactive views. For example, you can select left-hand side, front view, top view, bottom view, or you can select isometric views, improving spatial orientation and therefore eliminating any rotation confusion. There are a few enhancements built into the chamfer and corner rounding toolpaths, which we will cover first of all. But the main differences are the amount of model toolpaths available. In XR9 Professional, you have 6 in total, whereas in Onecnc10 Expert, you have 6 roughing cycles and 18 finishing cycles, giving you far more choice on the flow of the surfaces that you're cutting.
Onecnc10 cam enhancements. The new chamfering feature supports custom angle settings and allows the use of tapered tools, not just the standard 90 and 45 degree tools. The tool library has been updated accordingly, and multiple automatic passes are calculated when needed for optimal results. So let's go ahead and give you an example. So in this example, we're just going to use position number 1. We're going to go into chamfer and edge, give ourselves a start point, a direction, and right click to end as always. So if we just go into the libraries, as I said, the library has been modified to take all of the different taper angles that are now available, and obviously you can modify them to suit. We'll just grab hold of an 8mm chamfer tool. We'll just give it a 0.5 tip diameter. Not really bothered about speeds and feeds. So next. Quite happy with the clearance plane. As I say, this side of the form hasn't changed at all, apart from the graphics. The only difference you'll see, it does now offer you cut levels. And cut levels obviously come into play when you're using a smaller tool than the actual chamfer size itself. So we've got an 8mm tool. Let's do a chamfer size of 10mm. We're going to use cut levels, as I say. And when we select next, you can see all of these are auto selected. It calculates out the step over and the rough in depths dependent on the size chamfer and tool you've picked. They can obviously be overridden to suit. So for this one, we'll just leave the standard settings. I'm just doing a lead in and lead out slightly bigger than the tool radius and finish. And if I just right click and go to simulate rest, we're simulating to a stock model. I'll just slow it down as we go into it. And as you can see, it's just working along a single depth at the moment, just radially moving in at the given step over. Once it's finished this pec depth, it'll then drop down to the next pec level and work its way over at the same radial cut. And then finally, the cut right down at the bottom. So a very quick and easy way of modifying and creating chamfer cycles. So let's just go in and change a couple of these settings. So we'll go into edit. Let's say we thought the radial cut was a little bit gentle. So we're just going to untick the automatic. We'll say a step over distance of 1. We'll leave everything else pretty much the same. And we'll accept the form all the way through. And we can then right click and simulate. As I say, you'll see the radial cut is a lot greater than it was before. obviously depending on the material and the cut conditions you have. But a very quick and easy method of using chamfer tools to cut larger sizes. The new corner rounding function automates multiple pass calculation for accurate corner rounding, available in all milling and lathe multi-axis configurations. Users can expect better surface quality and improved life. So let's give you an example. So we're just going to go into our stock tool pass, corner rounding option, as usual, start point, direction, end point. We'll just change our tool over in the library. We'll go for an 8mm corner rounder and select OK. Again, I'm not really worried about speeds and feeds for this example. Clearance form is good. And we're going to use position number 1. So we're going to change it over to the outside. As I say, you can leave stock in Z for a finishing pass. It now offers us the roughing depth option. So we'll just go down in 2mm increments and we'll select next. We're just giving it a bit of a lead in, lead out, so it doesn't plunge onto the job, and finish. And we'll just do a very quick simulation with our stock model. So this comes in useful, obviously, for large corner rads, and as it states, it should give you a much better surface finish and tool life. Onecnc10 now offers us enhanced hole wizard. Hole features have been updated to allow for interactive model-based depth selection and improved feature recognition, saving time and ensuring consistency in repetitive tasks. This comes in especially useful when using things like drill hole single. Drill single, unlike drill hole wizard, does not give you the depth of the hole recognition. So when you're selecting the holes that you want to machine, we'll just go through the normal tool selection. When we come to the Pick Z option, now we can zoom in to the bottom of the holes, find an anchor point at the base of the hole, and left-hand mouse click. And that is telling us that the hole is 20mm deep. We can then obviously accept the form all the way through as we normally would, making Hole Wizard exceptionally simple to use.
In this section of the video, we're going to take a look at just some of the 3D model toolpaths available in Onecnc10, starting with pencil trace and area machining. In this example, I have already roughed this part out using Z-level high speed open and finished the top face and plateau using flat area machining, two toolpaths that you will be familiar with. For machining the 2.5mm radius, which in this example is a full radius highlighted in yellow, we'll be using pencil trace. Pencil trace just requires an extent boundary. So when we select the required toolpath, we can obviously select the correct size tool. Not really too worried about speeds and feeds for this example. Clearance, I'm quite happy with a rapid clearance of a couple of mil and a plunge clearance of maybe 0.5. We don't want to leave anything for finishing. We're using a picked boundary. I want the tool to be allowed to start outside the boundary. Top of the job is 0, bottom of the job is minus 2.5. And we can select finish, and then all we need to do is select the extent boundary and right click to end, and there we have it. For finishing this inside section, we could use a level finish, planar finish. Again, both of these two tool paths you will be familiar with. So this one we're going to use area machining. Area machining does not require boundaries. You simply select the surfaces that you wish to cut. Now you can select as many or as few as you like within inside the same toolpath. I'm going to select them all and simply right click to end. I'm quite happy with the 12mm tool for finishing. Clearance formula is good. Obviously step over depending on the surface finish that you actually require. I'll leave this one at 0.2 for simulation speed purposes, but you can go down to as small a step over as you like. We're going to spiral inwards, we're going to climb mill and finished. Give it a few seconds and you'll see the tool path working its way down to the bottom. So let's go ahead and simulate. We're going to right hand mouse click, go down to simulate rest. In this example we're just going to pick a boundary and select OK. Select the boundary, right click. So here we have the simulation. Just to speed things up, I will allow the first steps of the toolpath so you can see the reducing steps, but again you will have that technology in professional, and I'll just speed up and pause the video so you're not watching the same thing. And because obviously we've used the extent boundary, it's going to rough machine the flat area on the top as well. So the initial first pass on the flat area machining, just doing the large plateau. As I say, these tool paths you will be familiar with. Finally coming in and machining off the top face. And here comes the pencil trace. As I say, this is a size for size radius scenario. And then finally with the area machining. And this will just gradually work its way down at the applicable peck depth. As I say, I put quite a heavy one in really just for this example. But I will pause and fast forward so you can see the final results. So here we are, approximately a third of the way through the simulation. As I say, just working its way down, climb milling all the time. So there we are, 2/3 of the way through the simulation. And there we go. Two very powerful tools. One just using an extents box and selecting the required radius, and the other area machining, just selecting single or multiple surfaces.
Another toolpath available in the upgrade to 10 with inside the surfacing options is flow machining. Flow machining allows you to select single surfaces, multiple surfaces, steep, shallow, combination of the two, like the ones I've just selected. And then once you've selected them all, you simply then select the guideline that you want to follow and right click. I'm quite happy with the tool selection, quite happy with the clearance form. You can have a single edge to guide where you can go away or towards. You can have two edges to guide where you can work towards the center. I'm quite happy with the step over point 2. I've got a single guide edge and I want to work away from it. And there we have it. You'll see there's only 2 lifts. It's a very efficient program. And if I go into my back plot and just zoom in to this vertical face, you can see even though it is a vertical drop, you get constant cusp control all the way through the different options, whether it's steep, shallow, or vertical. So a very quick and efficient toolpath, giving you excellent finishes very quickly without the use of boundaries. So I'll just turn the back plot off and we'll do one more selection. So we'll do flow machining again. We'll select this bridge and right click. Again, we'll give it a guideline and right hand mouse click. Quite happy with the tool selection and finished. And there we have it. So just before we go into the simulation, I have already created a roughing pass and I've just simply done a Z level finish down the spout so that my tool won't hit the boss. So we're going to go into simulation. I'm using a stock model. And we'll just pause the video for a few seconds so you don't have to watch the Z level roughing. As I say, I did put a Z level finish down the chimney just so that my ball nose end mill didn't encroach it while machining. As I say, I'll just put this onto pause while it finishes that toolpath. So the chimney is about to finish, and there we go with our flow machining. Again, I'll just put this onto pause until we come to the vertical section. But as you can see, even running at 20% or 20 times, there's been a lot of work put into the graphics side of the software. So here we are at the section where it's just dropping down the vertical sidewall, and as you can see from the graphics, the cusp control works perfectly over shallow, steep, or a combination of the two, with no lifts apart from at the beginning and the end. So here we go, again flow machining, following the single drive line, just working its way over the bridge. So a very quick, simple, efficient way of creating extremely fine finish toolpaths with no variation, whether it's steep, shallow, or steep surfaces. Again, I'll just put this onto pause. We just come into the very top of the bridge. So I will turn the job around so we see what's going on. just working its way down the other side now. And there we have it. A very efficient and quick way to create perfect surfaces with no boundaries.
In one of the previous videos, we looked at pencil trace. Pencil trace is used when you have a common fillet radius all the way around the part. When you have the scenario of variable radiuses or radiuses blending into a tapered wall, we use valley machining. So when we select valley machining, obviously, as always, the first thing we do is select the tool numbers, the speeds and the feeds. I'm quite happy with a rapid Z plane of a couple of mil and a plunge clearance of maybe 0.5. I don't want to leave anything for finishing. Does your pencil area contain fillets? Yes, it does. The largest fillet radius on this part is 3 mil. Obviously, step over depending on the surface finish you're looking at. We'll just change that to maybe 0.2. I'm quite happy with 12 step overs, and we will select next. I'm just working with an extents box for this calculation and finish. Now for this one, we'll just preview the toolpath. So we'll right click, preview, and as you can see, the tool starts from the base of the component, radially moving in towards the applicable radius, and then works its way from the opposite side, from the tapered wall, back to the middle. So it's a very quick and easy way of creating, as I said, either variable fillet rads or fillet rads going into tapered walls. The final example for today is going to be using deburr. Now, deburr is not a chamfer cycle, it's a ball end mill, and the ball end mill does work to the solid model. So it's collision detecting itself all the way around. So when we go into deburr, we obviously select the tool, the speeds and the feeds. Quite happy with a couple of mil clearance. Depending on obviously the size of ball end mill that you're using, it will give you a maximum deburr amount, which in this case is 0.75. This example, I'm just going to show you that it will deburr everything it can see. So we're going to use extents box and finished. And as you can see, it deburrs everything. Now, obviously, in certain circumstances, you only want to deburr certain things. So I'll just turn off that original toolpath. We'll go into deburr. We'll stick with the same tool, same clearances, same deburr amount. And what we'll do now is select the edges and finish. It'll obviously prompt you to pick the edges to deburr. And let's say we just want this front row of tapered edges on the holes deburring. Now we'll deburr these little upstands, both sides, and we'll deburr that one section in the middle. And right click. And there we have it. A very, very quick and efficient way of deburring any kind of profile. And we'll just preview this one. And obviously the main advantages of using this style toolpath is, rather than relying on the operator having to go around there with a little deburring knife, or using a chamfer cycle and having to trim the edges off so it doesn't hit the model. There are obviously a lot of other options available within Expert. If you have any questions or would like to see any more information, please contact us at Onecnc UK. Thank you. Bye bye.